All right, we're back with Data Analysis 2, Part 4. I didn't have my phone handy to authenticate myself in the previous Part 3, but I've done that in the meantime here in Part 4, just to give you a brief glimpse of Sage Research Methods, which has various help learning tools for various data-related issues, and including this Which Stats Test sort of interactive quiz that walks you through a series of questions and then will recommend a test to you. So those are good getting started places. Now we're going to do correlation, and I'm going to stick to the numbering here and let this session be super brief with just the code for correlation. This is more to illustrate some of the odd behaviors of R in context, right? So I would like to get the correlation of two things, the GDP per capita and the fertility rate. So I just put those variables inside my parentheses with a comma in between, and I know that I need to eliminate not available data in many functions. Right? This standard code for that is na.rm equals true. However, R is a little odd and inconsistent because different things are written by different people, and it's an open environment. And in correlation, they don't use na.rm equals true. We again have to kind of look into the help whenever something breaks and realize that in this case the option is use complete obs instead. But if we do that, we get a correlation between two variables. In this case, only reporting the coefficient, right? So just negative 0.579, a negative relationship. If, on the other hand, we want something more complete, there is a second function in R. Often there are multiple ways to get things done in R. You have to kind of pick the ones you prefer or are familiar with. Core.test in this case does that. So core.test behaves a little more elegantly. It will automatically drop missing observations, and it will give you this more fulsome output, which has the same correlation coefficient reported, 5.79, but gives you a confidence interval for that, right? Because often we are, in this case, we're looking at, it's a small sample, 12 countries. Like, if that was a sample from a larger population, could we be very definitive about saying the correlation coefficient is negative 0.58? Now, this gives us some measure of uncertainty, and it also gives us a p-value. Like, is that a significant, statistically significant measurement? And in this case, it is. So that's core.test versus core, and illustration of a little bit of R's behavior. End of Part 4. See you in Part 5.